tap that switch and what do you get? You get electricity.
Mr. Dreiling, can you tell me what was the whole purpose of telling the kids a little bit about energy and electricity today?
Well, at Midwest Energy, safety is one of our main focuses, and in order to do that correctly, we have to go out and we talk to the young children in our communities, and we show them a little bit about how safety works, how sometimes it doesn't work like it should, how dangerous it can be, and also we have some fun. We do some experiments, a lot of hands-on things, and we also talk about conservation, about how expensive electricity is for us to produce and how saving it is a good idea. We use a whole different variety of visual effects. Behind us we can see that we have a mock-up of a town basically with power lines, people, vehicles, buildings, and we kind of show how different things use energy, how things could fail, and how people could get hurt if they don't follow the rules.
Jack, can you tell me one thing you learned about energy?
I learned that energy is just particles to run our everyday appliances.
Can you name an example that you use in the household that deals with energy or electricity?
A lamp, which is current electricity, so we can light our homes.
And what was your favorite part?
The static ball, because when you put your hand on it, your hair sticks up, and you can also shock someone maybe. And it's just really cool.
Did it hurt you when you got shocked?
No, not really.
Atoms, yeah. Are electrons part of an atom? Okay. What other parts are there in an atom? We have the electrons.
Protons and neutrons.
Neutrons and protons. Tell me something about a proton. Somebody holler it out.
It has a positive charge.
It has a positive charge. Well, somebody tell me something about electron then.
That it has a negative charge.
It has a negative charge. Hey, guess what electricity is? Electrons. That's all electricity is a whole bunch of electrons.
That's why they call it electricity.
There we go. So we have all the electrons on this side, right? What charge are they? Negatives. And then we have all the protons on this side. Well, they're positives, right? So how do you think we separate the positives from the negatives? Holler out.
The third comes on the slope.
The cord, that's the ground. Yeah. Well, the neutron is the neutral. How do we get the positives on one side and the negatives on the next side? How do we make electricity? Holler it out. Yeah. What do you think? We have power plants, right?
Yeah.
And in our power plants, we spin magnets that are positively charged and negatively charged. And we spin them as fast as we can. And we found that if we spin them just right, we can spin out the positives on one side, the negatives on the other. And that's all we do. We're going to see if we can make Alex make a little bit of electricity for us today. Alex, hop up here. Come on. Alex, hop up there. Put your hands up there, Alex. No. There. What's that look like you're going to do? Let's go. Go, Alex. Now, come on, Alex. Now look, Alex. Look down there. Okay. Keep going, Alex. The harder he goes, the more light bulbs he's going to get, right? Let's go, Alex.
Faster.
Come on, Alex. Let's go.
Go.
I'm not even getting one.
Come on, 3. Come on. You get it.
Go ahead.
Whoa.
There you go.
And you expect me to
Okay. So it works, right?
He got
It just takes a lot of energy.
He almost got 5.
He did get 5.
did.
I think he got all 5.
Yeah.
You only had 4?
I got 5.
You got 5.
I got 5.
You guys know that a regular light bulb like this, that 75% of the electricity that goes into that light bulb is turned into heat and only 25 into light. Think about that. 25%. So we ended up with light and heat, right? What was in this cord? Electrical energy, right? So we follow the cord back. What's this thing right here? That's the generator, right? It's the coil with inside, the copper coil inside of the magnets that spin. So what was spinning that?
Alex's arms.
Alex's arms. Okay, where did Alex's arms get that energy from? Those muscles, right? Where did your muscles get the energy from? Food, right? What you have for lunch today?
Taco salad and a salad.
Taco salad, okay? So what was in that taco salad?
Meat, corn chips,
Okay.
and I had a salad and tomato.
Salad and tomato. Let's think about the meat in that taco salad. Where'd that meat come from? Where'd it get its energy from?
Cat.
The cow, right? Everybody buy that? So where'd the cow get its energy from?
The grass. That's why.
The grass. Where'd the grass get its energy from?
The sun.
The rain, the earth, and the sun. No matter what we do, it always goes back to the earth and the sun. That's pretty important, right? Now let's talk about this. Let's pretend that Hope got all 5 of them lit. We have to pretend because she really only got 2, right? We're going to pretend she got all 5 of them. And because Hope is such a nice person, Midwest Energy wants to hire Hope to generate electricity for us. Yeah, we're going to hire her. And all we want her to do is generate electricity. And all she has to do is light up all 5 light bulbs for 5 hours. Hey, we're going to pay her. We're going to pay her the same amount of money that your parents pay for that amount of electricity. How much do you think we ought to pay her? 5 hours. $5. How much do you think we need to pay her?
$500.
What do you think your parents pay for that much energy? No? About 12 cents. Would you do it for that? No. No? Wouldn't help us out, would she? Now let's think about that. When your parents are at home and they tell you to shut off the lights, that you're costing them $1 million, right? Cost them all kinds of money. Don't they always tell you to do that? Shut off the lights? Cost them a fortune. Are you costing them a lot of money? No, you're not.
Yell at them. I'm costing you 12 cents.
There we go. But let's think about something else though. If I had to have Hope do this, and I had to feed Hope taco salads, how many taco salads would I have to feed her to do that?
12.
A whole bunch, right? So even when you're saving those little pieces of electricity, is it cost saving a whole lot of money? No, but think about what it's saving us. So we don't have to spend all that fuel, right? We don't have to buy taco salads. We don't have to buy and use all our coal and all our natural gas and all those other things. What do you call that? Conductor, right? Conductors carry electricity. So what's the opposite of conductors? Insulators. What are conductors made out of? Metal, copper. Rubber can be a good insulator. Glass can be a good insulator. Some plastics. Wood is very seldom a good insulator. Most of the time it is a conductor. If wood has any kind of moisture on it, if it has paint on it, oil, anything on it, it becomes a conductor. So how about a tree? Is a tree a conductor or conductor? Conductor, because it's going to bring that electricity right down to you. So trees are really, or wood is usually a pretty good conductor. Well, tinfoil is a conductor, right. Okay, watch what happens when I touch it. Ready? See it? You saw it? No. No, nothing happened. Watch what happens when I touch it down.
Whoa!
Electricity is coming out of the ball, in my hand, down my shoulder, across my heart, out my other hand, and back into there. We made an electrical circuit. You guys have been studying these, right?
Light bulb, dry cell wire. It sounds like it's
What's that?
Light bulb, dry cell wire.
There we go. So we made a circuit. Now, let go. Grab hands. Okay, what is she? She's our switch, right? She's either on or she's off. Hey, hurry up, guys, hurry.
I kick it in.
Okay. You guys are kind of cheating, but is that a parallel circuit? No. It's a massive parallel circuit because everybody's touching everybody.
Try to get over it. What about you?
Okay. So our lineman's job is to fix the lines when they go down. I mean, anybody know what happens when you take a piece of metal and bend it back and forth?
It's gonna break.
It's going to break. So what happens in the Kansas wind to our power lines?
It's gonna break.
They break. So what Allison has to do is she has to go out and find the piece of wire that broke and tie it back together again. Okay? So what we do, instead of tying them back together again, we give our linemen special deals like this. You see it, Allison? See how this works? See how easy that turns on or off of there? And what we do is we spin that off of there, we put the 2 wires in there, and we tighten it back up with our wrenches. Okay? Pretty simple, right? Lineman job is easy. Okay, Allison. Okay, you ready? Get started. Now let's think about this for just a minute. Are we standing in this nice media center doing this? No, they're hanging out on a pole and lightning's coming down around us and it's snowing and raining and cold. What I want you to do is look at the light and see if you can follow the flow of electricity. Here we go. Ready? See it go in her arm? And where's it going out?
Her leg.
Her leg, right? Because it's going to the ground.
Jacob, what's one thing you learned about energy today?
That if you stuck something up in the air, it shorts electricity in the wires.
And what was your favorite part?
The static ball thing.
Oh, where you stuck your hand on there?
Yeah.
Did you like shocking people? Yes.
Yeah, he stuck his hand really close to my hand, and he had a ring, and it had a lightning bolt go.
Shelby, what's one thing you learned about electricity?
That there's over like 500,000 volts in like a power line.
And what was your favorite part?
When my hair stuck up and I could shock people.
That's awesome.